Hello and welcome to the YouTube channel of Kendra Engineering College, Mangalore. In this video session, we'll check regarding the applications of op-amps. In the previous video sessions, we have already checked regarding two important applications of the op-amp. One of them was peak detector circuit and other one was Smith trigger circuit. Continuing with our study on the applications of op-amps, we will look into one of the very major applications of op-amps which plays a very important role in the field of electronics and communications, that is filters. So we'll check out what are these filters, how are they built, and what are the broad categorization of the filters, and how do they perform. So the topic what we are going to check out now is about active filters. So before looking into this active filters, we'll check out the second term which says filters. So basically when I speak about filters, filter is a very normal term what we use in our day-to-day life. So normally why do we use filters? Filters are used to remove the unwanted things. Very similarly, in the field of electronics and communications, filters are used to remove the noises. Noises are the disturbances of unexpected frequencies that occur in communication. So it's given here technically. Filter is a frequency selective circuit commonly used in signal processing that passes signal of specified range of frequencies and blocks the signal of frequencies outside the band. So basically what your filter is going to do is, so if I consider this to be my filter, and if I'm randomly passing the signals of various frequencies, this filter is going to allow only the specified frequencies to pass through them. The unspecified frequencies will not be allowed to pass through this particular filter. So when I speak about this filters, they are going to filter the signals. So that is what it is given here, that will pass the signal of the specified range of frequencies. So whatever frequencies you allow to pass, those particular frequencies will be allowed to pass through this, whereas the signals of unwanted frequencies or the noises will all be filtered out. Active filters are basically attractive. Normally when we speak about filters, we always speak about active filters. Basically there are various categorization of the filters which we will check out in the next slide. So basically why does active filters have gained the popularity, or why it has grabbed the attention of the people is flexibility in the gain control. As I said you, my filters are going to be designed using op-amps. So whenever I speak about the op-amps, they need to be having the gain. So flexibility in gain control. You can be, or you can adjust the gain of this particular op-amps. There is flexibility in the gain control. You can control the gain of this particular filters. The component size, the filters what are designed or what are manufactured using op-amps are of small size, no loading problem. That is, this filters which will allow the frequencies to pass through this signals can be fed to the device what is in need of this particular signal. So there is no loading problem. The signals what is passing from the filters can be directly made available to the devices what are in need of this particular signals. Pass band gain. Normally the gain of the pass band will also be high. So normally when I speak about signals, let us say it's the pass band. This is what is called as pass band, right? So this is lower frequencies, this is higher frequency. This is called as bandwidth. This is called as bandwidth. So, or you can call it as pass band. You can also call it as pass band. You can also control the gain of this pass band. It is possible to control the gain of this particular pass band. The very important among all the factors here which is which is making active filters gain the popularities, the inductors are totally avoided. You are not using any inductors in your filters. Normally when we speak about inductors, inductors are the passive devices which will consume lot of space and which will get heated up very easily. So normally in case of my active filters, I do not use any filters. Coming to the general classification of the filters, filters are broadly classified into digital and analog filters. As we are not interested in the digital filters right now because we are already done with the digital electronics, we'll concentrate only on the analog filters. So analog filters basically can be categorized into passive filters and active filters, out of which active filters are very commonly used in the industries. Let us check what are the differences between this active filters and passive filters. So speaking about active and passive filters, in case of your passive filters, you use all the passive components, resistors, capacitors and inductors, which means this particular filters are built up using the discrete components. They are not available in the form of the ICs. You need to build the filters using the discrete passive components. Coming to this particular active filters are available in the form of the ICs, and they are broadly made up of op-amps, transistors and resistors and capacitors. Inductors are totally avoided in case of your active filters. In case of your passive filters, as they are built up using discrete components, they need external power supply. They need to be having external power supply, which makes them incapable of providing power gain. Whereas in case of your active filters, no external power supply is needed. That makes them capable of getting the power gain. Next advantage of your active filter is, in case of your passive filter, the stability is better and it can stand large variation of current. Quite obvious because it is made up of discrete components, right? Whereas coming to active filters, stability is comparatively less. It will normally lead to oscillations and noises when we go with the feedback loops. Or normally my active filters will be prone to noises and oscillations which is not present in the active filters. So active filters are comparatively, or they have their own advantages, and passive filters do have their own advantages. A passive filter has got no frequency limitation. It can operate in any frequencies, whereas my active filters has got a frequency limitation. Passive filters are bulky. Normally the size of these passive filters are comparatively higher because I use discrete components. Active filters are compact because they do come as ICs or integrated circuits. Normally, when I speak about discrete components, or you need to buy individual components and you need to rig it up together, normally the fabrication process will be complicated. It is difficult to fabricate in the IC form, which means that it is impossible. My passive filters do not come in the IC form, they always come in the discrete component form itself. Whereas active filters can be fabricated into an IC form, which makes them compact and less space consuming. So active filters has got more advantages when compared to the passive filters. Passive filters will also have some advantages. It has got some 2 to 3 advantages which makes it better than the active filters. In spite of having better advantages, people prefer active filters because they normally concentrate on space consumed, they normally concentrate on the the power consumed, and they also concentrate on the fabrication process, and they concentrate on the cost of this particular device. As I said you, active filters has got following advantages over passive filters. Gain and frequency adjustment can be done, which means that you have flexibility in adjusting the gain and the frequency. Loading problem is not there. You do not have any loading problem. You can directly connect the output of this active filters to any devices of your choice. Size and weight. Size and weight means because it comes in terms of a IC. Also the cost is less. The most commonly used active filters in our industry or in our day-to-day life are low pass filter, high pass filter, band pass filter, band stop filter and all pass filter. Let's check all these filters one by one, but broadly let us know that what are filters and what are the components that basically build up a filter, or what are the components that actually make up a filter. Based on the frequency responses, we have different categorizations. I told you already here, right? Low pass filter, high pass filter, band stop filter, all pass filter or band reject filter. So basically this categorization is done based on the frequency response of this particular filters. So if you speak about the low pass filter, this is the frequency response of your low pass filter. Low pass filter means it allows signals of low frequencies to pass through it, whereas the high frequency signals will be blocked. From the frequency response itself, you can know it. The lower frequencies are allowed to pass, whereas when the frequency crosses the higher frequency, the frequencies or the signals are not allowed to pass. This is called as pass band, this is called as stop band. When we speak about high pass filters, low frequencies are not allowed to pass. After the cutoff frequencies, the frequencies or the signals which are having higher frequencies are allowed to pass through it. So this is what is high pass filter. Band pass filter is a filter which will allow only a specified frequencies to pass through it. It will neither allow lower frequencies, it will neither allow higher frequencies. It will allow only a range of frequencies to pass through it which are between the lower frequency and the upper cutoff frequency. So this is what is band pass filter. Band reject filter is it will allow lower frequencies to pass through it and it will allow higher frequencies also to pass through it. Only a band of frequencies, only a narrow band of frequencies will not be allowed to pass through it. A band of frequencies which comes between FL and FH, that is lower frequencies and higher frequencies, will not be allowed to pass through it. This is what is called as band reject filter. So this categorization of the filters is based purely on the frequency response of the filters. Now let us check out the filters what we have seen here one by one in terms of its construction and in terms of its components. So first order active low pass filter. Let us forget this particular first order right now. Let us concentrate on active low pass filter. So when I speak about low pass filter, you need to understand that when I go with the frequency response, it will allow only the low frequencies to pass through it and the higher frequencies will be blocked. So this is your FH, this will be your gain and this will be your frequency. So only lower frequencies will be made to pass through it, the higher frequencies will be stopped. Pass band and stop band. How this is actually constructed? That is constructed using op-amp and capacitors and resistors. So you can see there is a feedback path which is existing. There is a resistive feedback path which is existing from the output back to the input, and also the input is given to the non-inverting terminal. Now if you are asking me, sir, what is actually acting as a filter here? The basic component which acts as a filter or which will be allowing the lower frequencies to pass through it is R and C. The R and C connected, that is R connected in series with the non-inverting terminal and C connected in parallel with the non-inverting terminal forms a low pass filter. Why do we call it as a first order active first order S? Because it has got one pair of R and C. If my filter has got one pair of R and C in the path of the signal what is going to be filtered, those particular filters are called as first order. So do you have second order and third order? Yes, we have something called as second order, third order or fifth order filters. For example, let us say that you pass the signal, you are not happy with the output. You say that I wanted still more frequencies to be sorted out. I want still more frequencies to be removed. Then what you do is you can connect one more filter ahead of it. That is, you can take one more resistor and one more capacitor and you can connect to it, which means the filtering efficiency will increase. So if you connect only one pair of R and C, this forms a first order. As it passes only low frequencies, you call it as low pass. As it uses only op-amp and resistors and capacitors, we call it as active. So this is the circuit diagram of your first order active low pass filter. See, the frequency response is given here. See, you can see the low pass is being passed. After the higher frequency it is being stopped. The frequency till where it is passed is called as pass band. After that it is called as stop band. The gain of this particular filter is given by 0.707 times AF. 0.707 times AF. From the graph, the gain AF is almost constant for the frequency range. That is, they are saying the gain is almost constant from 0 to FH, which means it is allowing lower frequencies to pass through it. At cutoff frequency, the gain is 0.707 AF. After cutoff frequency, the gain is decreasing. You can clearly see the gain is decreasing. The decreasing rate of this gain is 20 decibel per decade. Normally, first order filter gain will be decreasing at a rate of 20 decibel per decade. The cutoff frequency FH is given by 1 by 2 pi RC, where R is the value of the resistor and C is the value of the capacitor of the filter what you have connected. Passband gain can be given by the formula 1 plus RF by RI. Using this particular formula, we have got the equation 0.707 times AF. So that is given by the equation here 1 plus RF divided by R1. So that gives the passband gain. The gain of this particular filter in the passband region is given by this particular formula. So formulas has to be remembered. You need to remember this formulas when we are going with the sorting of numericals in the later part. Moving on further, second order low pass filter. As I said you, if you are not happy with the filtering, you can add one more filter or one more RC component can be added. This is your first component and this is your second component. Is it visible to you? So this is the first one and this is the second one. As you have added one more RC component here, this particular filter is called as second order low pass filter. Rest of the component all goes out to be the same. Rest of the component and rest of the design all turns out to be the same. There are no changes happening here. There are no changes happening here at all. You can find RF, you can find R1, you can find the op amp, you can find the input, you can find the output. The frequency response is also the same as that of the previous one. But remember, in case of your second order low pass filter, the gain after high frequency or after the pass band will be dropping at the range of minus 40 decibel per decade, whereas in the previous case it was only 20 decibel per decade, whereas in case of this one it is dropping at the rate of 40 decibel per decade. The cutoff or the high frequency is given by 1 by 2 pi R2 square root of R2, R3, C2, C3. In case if your R2 is equal to R3 and C2 is equal to C3, then you get the same formula what you had for the previous one. The passband gain is given by the same things because normally this is the feedback path which sets the gain of your op amp. When you say that op amp has got a gain, that op amp is actually set by the feedback resistors that exist in the feedback path. So gain of your op amp which is used in order to design this particular filter is basically set up by the resistors which is present in the feedback path. Circuit has to be remembered. Circuits has to be remembered here. Going on next, high pass filter. So this is also an active itself. First order high pass Butterworth filter. Normally Butterworth is a word which has been given as a matter of honor to the person who actually invented this particular filter. So first order high pass filter. High pass means what? It will allow only the higher frequencies to pass through it, lower frequencies will be blocked. Lower frequencies will be blocked, higher frequencies will be allowed to pass through it. These filters are called as high pass filter. How the design is actually running. So if you check the design here, my design of the low pass and high pass filter is almost the same, except interchange of R and C. Your R was actually here and C was actually here. So this R and C has been interchanged, making your low pass filter to be a high pass filter. Other than that, there are no changes at all. At low frequency, that is F less than FL, my gain will be less than V naught by Vin. V naught is nothing but gain is normally given by output voltage by input voltage, right? After that, the gain increases at the rate of 20 decibel per decade. It increases at the rate of 20 decibel per decade. At cutoff frequency, also the gain is same, 0.707 times AF. After high frequency, the gain remains constant. Yes, it should remain constant. The cutoff frequency is given by 1 by 2 pi RC. Very similar to the previous one, nothing else. Only the way in which you are connected RNC has changed here. Other than that, it doesn't allow or it is not making any changes with respect to the construction of your high pass filter. Passband gain is also given by the same formula, AF divided by 1 plus RF divided by R1. This is all it happens in case of your high pass filter. Moving on to second order, no changes except second pair of R and C getting connected here. Second pair of R and C getting connected here. Other than that, coming to the response, you can see the gain increasing at the rate of 40 decibel per decade. Because I've added one more R and C component here, right? It is increasing at the rate of 40 decibel per decade. Other than that, all the formulas for frequency, that is lower cutoff frequency, and the gain remains the same with respect to what we have studied previously. So there are no changes occurring here with respect to your high pass and low pass filter in terms of the formulas. Other than that, the construction wise they do differ a little bit and the frequency response wise they do differ. Now moving on to the next one, band pass filter. So band pass filter means it is a filter which will allow only a particular band of frequencies to pass through it. So this filter should be it should not allow low frequencies and it should not allow higher frequencies. It should allow only high or middle range frequencies to pass through it. So active band pass filters provides an effective means of making a filter to pass only a given band of frequencies. Only a given band of frequencies has to be passed. Now active band pass filter can be cascading, a low pass filter and a high pass filter. What is low pass filter doing? Low pass filter will allow higher frequencies to pass through it. Higher frequencies, high pass filter will allow lower frequencies will pass through it. So by cascading them together, you can get a band pass filter. The block diagram has been shown here. Input is given to high pass filter, which will allow only which will actually block the initial frequencies. The initial frequencies will be blocked. After that, the output is given to the amplifier. From the amplifier, it is given to the low pass filter. Low pass filter will allow only the lower frequencies to pass through it. Higher frequencies will be blocked. The quality factor of this particular band pass filter is given by Fc divided by Fh minus Fl. We'll check the response of this. So band pass filter, this is what is band pass filter. So if we can check out here, as I said, I need to have a high pass filter, I need to have a low pass filter. Intermediately, I need to have an amplifier. So you take an high pass filter, amplifier is already present here, so no issues with respect to this. The output of the high pass filter is given to the low pass filter. Once the output of the high pass filter is given to the low pass filter, the higher frequencies will be stopped. This is going to stop the lower frequencies. Only a band of frequencies are actually allowed to pass through this particular filter. That's why we call this as wide band pass filter. And this pass band is actually decided by you people. You can decide what frequency should be allowed and what frequency should not be allowed based on the values of the C and R, based on the values of R dash and C dash. So this is your band pass filter. Moving on further. This is a simplified version of your band pass filter. So you can see here. Please concentrate. A capacitor and a resistor are connected here. See this one, or you consider this one. Resistor is taken here and capacitor is taken here. This is very similar to this one. Low pass. After that, you take a capacitor and you take a resistor. That is this one. This forms the first one. This forms a high pass. This is high pass. They are both clubbed together and the circuit has been simplified with respect to the previous circuit. This was the complicated circuit. The same circuit can be simplified and you can use a single op amp and you can rig up a band pass filter. For example, if you're asking me, this is a single stage, right? This is a first order, right? How do I go with the second order? You can add on the resistors and capacitors here. You can add on the capacitors and resistors here, which makes up a second stage or which makes it up a second order. So normally your intention is what you know, your intention is to remove the signals of unwanted frequencies. Whether it is lower, whether it is higher or whether it is band pass. It's your choice what you want to allow. That allowing can be done based on the resistors and capacitors what you actually use in the manufacturing. So narrow band pass filter, that one was the broad band pass filter. This is a narrow band pass filter. Narrow band pass filter is basically it will allow a little frequencies to pass through it. It will allow only a little frequencies to pass through it, and the circuit diagram for the same has been given here. So circuit diagram for the same has been given here. The resistors R2 and R1, what you can see here, the resistors R2 and R1 are basically used to set the gain. They are used to gain the or set the gain of your filter. Cutoff frequency is actually the components are same, okay? Components are R1, R2, C1, C2. Quality factor is given by Fc divided by bandwidth, 1 divided by root of R1 divided by R2. Gain is given by this particular formula. So normally I don't think they will have a questions on the narrow band pass filter. If they have questions, they will have it on the high pass, low pass, first order, second order and broad band pass filter. Narrow band pass filter, as far as I am concerned, they will not have questions on this because the amount of frequencies what is allowed to pass through this particular filter is very limited. It will allow only a minimum frequencies to pass through it. And you can see this drop in the bandwidth. Here it will be increasing at the rate of 20 decibel per decade. Here it will be reducing at the rate of 20 decibel per decade. All the things with respect to the things what we have studied with respect to your first order and second order filter itself. No changes with respect to the functioning of your filters. Wide band reject filter. So this is one of the thing which is somewhat different from the things what we studied. Wide band reject filter. Band reject means what has to happen, you know? It has to reject the lower frequencies and it has to reject the or wide band reject filter. Yeah, it has to allow the lower frequencies and it has to allow the higher frequencies. Previous one was band pass. This is band reject. So it will allow lower frequencies and it will allow higher frequencies to pass through it. Only a band of frequencies will be blocked. You can see a band of frequencies getting blocked here. And that particular filter circuit is given here. But they are connected in parallel. In case of your band pass filter, what you used to do was you used to connect your high pass and low pass filter in series. Whereas in case of your band reject filter, low pass and high pass filters are connected in parallel and the output of both the filters are connected to a amplifier. This is a summing amplifier. Whereas in case of your band pass filter, you had the summing amplifier between the low pass and high pass filter. In case of this one, your summing amplifier or amplifier which was used in between the low pass and high pass filter is connected at the end, which will be taking up the work of amplifying the signal what is given by the low pass and high pass filter, and this is how the frequency response will be if you plot it in a graph. If you plot it in a graph, this is how the response is going to be. So low pass is allowed, high pass is also allowed to pass through this particular filter. Moving on to the next type of filters, this is called as narrow band stop filter. So similar to the one. In case of previous one, what was happening was, in case of previous one, the response was like this. Whereas in case of your narrow band stop filter, the response is narrow. It will block only your little frequencies. Other than that, almost all the frequencies will be allowed to pass through it. The circuit diagram for the same can be seen here. You can see a single op amp here, which is called as notch filter. This basically does the function of summing amplifier. The filtering function is done by this particular capacitors and the resistors. This basically forms a twin T network. You can see one T network here and you can see one more T network here. Higher frequency, lower frequencies are allowed to pass through this particular resistors. R1 and R2 will be allowing the lower frequencies to pass through. Higher frequencies will be allowed to pass through C1 and C2, which means that this twin T network will be working one by one. One T network, when it is working, it will allow only the lower frequencies to pass through, and the other T network will be allowing the higher frequencies to pass through. Only a smaller band of frequency, a very small range of frequencies will be blocked by this particular filter. And you can see there is a feedback that is connected here, which basically functions as a feedback path, helping in deciding the gain of this particular amplifier. The formulas with respect to this is already given here. Formulas with respect to your band stop, low pass, high pass, first order, second order, wide band pass, narrow band pass, band reject, narrow band reject filters has to be known by you people. High pass and low pass filter, there are no changes in the formulas. The formulas remain the same. Only the band pass and band reject filters, you need to remember the formulas in case if they ask you to design any of the filters. In case if they ask you, then you need to be designing the circuits. Designing the circuits, they normally in the designing part, you need to find out the value of R and C, nothing else. The value of R and C has to be calculated. In order to find out the value of R and C, you probably need to know the formula for FH or maybe FL or maybe FC or maybe AF. All these formulas need to be known by you people. Only if you know the formulas, then you can substitute those formulas and substitute the values what is given in the numerical and find out the value of R and C. So this is regarding the filters.